use this foldable to keep track of all of our formulas for surface area. Again, for this foldable, you'll need the foldable that says surface area, along with some scissors and a pencil to write with. First thing you need to do, just like all of our other foldables, is fold it in half on the solid line. After you've folded it in half, you're going to cut along the dotted lines, but make sure you only cut the first layer. For today, we're going to start with our notes on surface area of a cube. Alright, our general formula for the surface area of a cube, again, we're going to write surface area as SA for surface area, and then down below, as a subscript, I'm going to write cube, so I remember it's for a cube. And our formula for this one, since over here it's listed as D, we're going to say D times 6. And the reason this is the formula is because D times D is going to give us the area of one side, so the height maybe times this side over here will give me the area of one side, and since it's a cube, all 6 sides are the same. So we're going to multiply it by 6. For example, we'll draw a cube, and now we're going to replace the D up above in our equation with the 3 since our side length is now 3. That gives an equation of 3 times 3 times 6 for our surface area. 3 times 3 is 9, and 9 times 6 is 54. So the surface area of this cube would be 54 inches squared. Now we'll move on to the surface area of a rectangular prism. This is where our formula starts to get a little bit more difficult and your notes might come in a little bit handier. So we're going to do the surface area of a rectangular prism. And that formula looks like this. 2, and then times in parentheses, length times width, plus length times height, plus width times height. So the reason that this formula is written this way is because this allows us to either use the distributive property or we can simplify the parentheses first. Either way though, what we're doing is we're taking the length times the width, so length times width, that would be the area of the bottom rectangle, and there are 2 of those because the top rectangle is also the exact same. We're going to add that to the length times height, which would be length, this measurement here, times height, so that's the front and the back of this box, or this rectangular prism. And we're going to add that to width times height, which would be width times height, which would be the 2 left and right sides of this rectangular prism here. So essentially it doesn't matter what order these are in the middle here, inside of your parentheses, but they do need to have every combination possible and then add them all together and multiply it by 2. So here's an example. So if we're using our formula up above, we're going to multiply 2 times the length is 5 times the width is 3. We're going to add that to the length of 5 times the height of 2, and the only other combination we haven't had is the 3 times 2, so we're going to add it to 3 times 2. Now to simplify this here, I'm just going to simplify by multiplying each one first. So 5 times 3 is 15. Adding that to a 5 times 2 is 10. Adding that to a 3 times 2 is 6. That's still in parentheses. Now we'll add these all together here. That's going to give us a 2 times 31. And 2 times 31 is 62. And then it would be units squared. Our final one for today is the surface area of a triangular prism. And triangular prisms are by far the most challenging to find surface area for. But keep in mind, surface area just means we're finding the area of each surface and we're going to add them all together. Okay, so here's one way that we can write it. Surface area of a triangular prism. One way that we can write it, this gets a little lengthy, but it does work, is base times height plus 2 times length times the side plus length times the base. Okay, so again, I'm just going to write this in here as a little note. We're just going to add areas of all sides. That's really what we're doing here. Okay, so why is this formula written this way? Well, base times height, we see here this is base times height. Those are both measurements on this triangle edge. And you might remember that to find the area of a triangle, you would take base times height and divide it by 2. But essentially what we're going to do is we're going to take that formula and we're going to do it again because there's another triangle on the other side. So we really have two. So the multiplying by 2 and the dividing by 2 cancel each other out and leave us with this base times height. So right here, this is actually the triangles. Okay. Then we have 2 times length times side. Well, we'll see here that this is our length, and the side measurement we actually don't have a label. The side measurement is this one right here. So length times side, length and side being multiplied together is really finding the area of this rectangle on the side, and we have 2 of them because on this opposite side over here is also another triangle or another rectangle of the same size. So that's why we're multiplying by 2. So we'll say these are rectangles. And then we have length times base. So that's length down here times this base right here. And that's this single rectangle at the bottom that's actually a different size than our other 2 rectangles. Okay, so this is a single rectangle right here. Okay, so let's do an example real quick. Alright, so let's break this down real quick. Here we have 4. That's going to be our base measurement. 3 is our height measurement. 5 is our side measurement. And we have over here an 8 for our length. So let's just substitute everything in up here. Up above, our base measurement was 4, so we have 4 times a height of 3, plus 2 times the length, which is 8, times the side, which is 5, plus the length of 8 times the base of 4. Now we're going to put these all together here. Using our order of operations, we have to do the multiplication first. So we get 4 times 3 is 12, adding that to a 2 times 8 times 5, which is 80, and adding that to an 8 times 4, which is 32. And then we're just going to add those all together, and we end up with 124 units squared, which would be our surface area for this triangular prism. Make sure you put these notes in your binder so that you can use them on homework and for tests.